This lesson is going to go with Chapter 4, Scatterplots and Correlation. It's going to walk you guys through the scatterplot activity, teaching you how to use Excel to get a scatterplot, and then also find the correlation and interpret what that means. So when you go to page 149 here, we're going to look at this example. It gives you a bunch of data on two different types of cars and how well they do with city miles per gallon and highway miles per gallon. So you guys need to start an Excel file with those. I'm only going to do the first 5 cars here, just to save some time. You don't care about the name of the cars. All we care about is the data. So whatever car this is gets 23 cities, 31 highway. So I merged these two cells together here just to get proper titles and all that. Make sure you guys fill in the rest of the data in here according to page 145. Okay, so once you have it, we want both of these on the same graph to kind of look at them. Okay, we could easily do 2 separate things, but when they're both together, they're on the same scale. So we can do, highlight these, insert scatter plot, and then choose this one, and they'll come up like this. So this is the mini subcompact. So we want to get that labeled so we know that the blue dots are this. So right click on one of the points. We're going to add a trend line. Okay, this is going to be our least squares regression line, which we're going to get to next section. It's going to show us, if you were to put a line through these, how well would it look? It's also going to help us find correlation indirectly. So we want a linear, and you want to check these 2 boxes down here at the bottom, display equation and display r squared. So we hit close. So the equation of that line, you can see the slope there times x. You can see the y-intercept if this line kept going. Now, so I know what that is, I'm going to come in here, and I'm going to do 2 things. Up top, I'm going to label this mini sub, so I know that this data goes with that. Now here's r squared. Okay, r squared is 0.902. I talked to you guys about that r is our correlation. So if we know that r squared is 0.902, we want to find r. All we want to do here is say equals SQ. We want to take the square root of that number. So I'm going to come in here, and just below it, I'm going to say r equals 0.9497. Okay, that's the correlation. Okay, r squared's not correlation, r is correlation. Okay, so there's one of them there. We want this 2-seater on the exact same grid. So we're going to right-click on one of the blue data points. We're going to go to Select Data. This table will come up. Now, when it says Series 1, we can change the name of that so we know what it is. So we can click on Edit, Series Name. You can type in Mini Sub Compact. It's already got the data in there for you. So now your graph, it'll show the blues are those. All we want to do now is click Add. So we're adding a series, basically. Okay, this screen will come up. Series Name. Put in 2-seater, come down to X values, highlight all of your X values, there's more than just 5. Come down to Y values, for whatever reason it has an equals 1 in here, get rid of all that stuff, and then highlight all your Y values, click OK, and now when you look at your graph, you got red is 2-seater, okay, you got the blue is the mini subcompact, and you can talk about direction, form, and strength for both of those. We got to do the exact same thing for the red one in order to find the R. So make sure you're on a red point or you have the red points highlighted. Right click, add the trend line, click these 2 things, come down here, you can move it down here if you'd like. Now this equation is going to be different than your guys's because I only have 5 data points, you're going to have more. So in here, we're going to call this the 2-seater so we know which one it is. We're going to come down here and say, all right, if r squared is 0.8411, Then the r that I care about is just going to be the square root of this number, 0.917. And that again is our correlation. So if you get a correlation of 0.917, that's very, very strong, positive, and linear. You get a correlation of 0.97 or 0.9497, that's very, very strong, positive, and linear. Okay, correlation of 1 would be exactly the, the lines fall on the dots fall on an exact line. So this information here will be enough to get you guys going on answering the questions for this exercise in here. I do give you this last little step here as far as formatting the axis and starting the x-axis a little bit later, because this range in here is just kind of wasted space, so we can kind of adjust the scale. Remember we talked about don't let your eyes fool you. Things can look more spread out when you adjust the scale. That's why we always find R's to relate them. Okay. The next problem is going to have you guys do crawling age and average temperature 6 months after birth for babies to see if there is a correlation between those. They have the birth month in there. You're not going to care about those. So you can just go to a brand new sheet. You can do it on the same sheet. It doesn't matter. All you're going to care about for the next problem is average crawling age, and then the average temp. The birth month doesn't matter. Okay, that's just extra data in there. That will take you through the exercise 4.8. The last two I ask you guys to do are these ones, 4.13, 4.14. They deal with women and men's heights and a research question. When you're doing these, not only do you have to do the scatter plot, but they ask you some questions. So I want you to think about our key points. We said correlation is direction and strength, and it's only for linear associations. Correlation does not change when you change units of measurements. You go inches to centimeters, correlation's the same. Correlation doesn't care what the explanatory and the response are, because you're just multiplying the two variables together. So it doesn't distinguish, and it's strongly affected by outliers. So with that, one of the questions asks you something like this. So how does R change if one variable drops the same amount? So here's some x's, 1, 2, 3, 4, 5, and the exact same x's. Here's some random y's, 5, 8, 11, 14, 17. They're all going up by 3. We change the units here. If these are inches, feet, whatever, and we change them, correlation stays the same. So this line here is the one in the blue. So I did a trend line. So R squared's 1. So correlation is 1. Okay, you can't have anything stronger than that. Over here, all I did, it says starting at 5, I started at 10, 8 to 13. So all of these are just 5 bigger than all of these. R squared again came out to 1, so that means when you square root it, our correlation is also 1. So think about what happened here for this question there.